Okay, so what we're going to talk about is converting in a circle, converting radians to degrees. We've already talked about converting degrees to radians, now we're going to talk about converting radians to degrees. So first of all, let's review exactly what a radian is. Now when we talk about the degrees in a circle, so we'll put degrees in red. When we're talking about degrees, there are 360 degrees in the circle. So if I were to put an angle here, if I were to make this an angle all the way around, this whole angle would be 360 degrees. That's why this angle would be 90 degrees, and this angle would be 180, and this angle would be 270, and this would be 360. So the degrees in a circle are the angle and arc measures, not arc length, the angle measures and the arc measures in a circle. So I'm going to put that here, angle and arc measure. It's important. There's a difference when we're looking at measure and length, okay? So that's 360 degrees. Again, is 4 90-degree angles, 360 all the way around. Just like if I did only this, that would be 180 degrees because I'm only going half the circle. So that's what the degrees are, and we'll circle that. So there's 360 degrees. Now on the flip side of that, we have what are called radians. And radians, let's use a pen that works. Radians are lengths. Okay? Radians go from 0 to 2 pi. Now what in the world are we basing radians on? Radians is actually the arc length. The radians are based on the circumference. Let's look at my circle here. This is the unit circle. It's got a radius of 1, correct? You can see I've written a 1 there. So since it has a radius of 1, what would the circumference be? Well, isn't circumference 2 pi r? Right? 2 times pi times radius. So if circumference is 2 pi r, then that means if I plugged in 1 for my radius, what's my circumference? 2 pi. That means once around the circle is 2 pi. If I'm actually looking, 2 pi, not 2 pac, by the way, just in case you were wondering. So if I go all the way around here, this full circle is 2 pi. That's 2 pi radians. That is the circumference of the circle. All radians are based on the circumference of a circle, the unit circle, with a radius of 1. So we want to convert from radians to degrees. So what do we know about every radian? Okay, about the radians. Well, if 2 pi radians is 360, pi radians would only be 180, right? Because if the whole way around is 2 pi, halfway around would be only be pi, right? Okay, so here's how you convert. If I have a pin that works, if I've got, for example, let me push this up a little bit. Okay, let's say number 1, I have 3 pi over 2 radians. 3 pi over 2 radians, okay? That basically means I've got 3 pi over 2, it's a portion of the circumference. If the circumference I'm looking at with a radius of 1 is 3 pi over 2, how many degrees is that? Well, let's look. So the way you convert, and usually let's use a different color because you guys like different colors. The way that you convert is you multiply radians, the factor is, times 180 over pi. Now why are we doing that? Do you remember in science where you did conversions and we would convert things? Okay, so for example, I'm going to give you a sample conversion before we do this, just to kind of show you. All right, let's say we have 2.5 feet, and I want to convert that to inches. All right. Let me get that back on the screen here. I have 2.5 feet and I want to convert that to inches. What do? Well, most of you can do that. You say, oh, it's easy, it's times 12. Okay, why do you multiply by 12? Well, this is why. 2.5 feet. I'm going to convert. To convert, I have to get rid of the feet. I want to go to inches. But what do I know? 12 inches are in every 1 foot, right? So when I multiply across, I'm going to get feet times inches on the top and feet on the bottom. Well, what cancels out? Feet and feet. So 2.5 gives me 30, and then all I have left is inches. So I've just converted from feet to inches by doing, well, if I have 2.5 feet, and I know that there's 12 inches in every 1 foot, how many is that? Conversely, going the other way, let's say I have 30 inches, and I want to convert that back to feet. Well, I know that I'm going to convert from inches, and so there is 1 foot for every 12 inches, right? Same thing's going to happen. On the top, I'm going to get inches times feet, and on the bottom, inches. So what cancels? Inches. So I'm left with 30 over 12, 30 feet over 12, and when I reduce that, it's 2.5 feet. So that's an example of where you've used it before, and you use it all the time. Most of you can convert from feet to inches and inches to feet pretty quickly because you know there's 12 inches in a foot. Well, there's 180 degrees for every half a circumference, every pi radians, right? So I'm doing the same thing because now what's going to cancel out? The pi's are going to go away. So I'm going to end up, because if I didn't cancel them, I would end up with this, 540 pi over 2 pi, right? And that's where they cancel. But I'm just canceling them ahead of time because I can see they're going to go away. And 540 divided by 2 is 270. So 270 degrees is half the circle. Is 3 pi over 2, which is actually 3/4 of the way around the circle. Okay, so it's 270 degrees. Let's do another example. All right. Let's make this simple. If I want to convert pi radians to degrees, okay, if I want to convert pi radians to degrees, I multiply by 180 over pi, right? Because there's 180 degrees for every pi. Well, what's going to happen here? I can go ahead and multiply it across if I want to. I'm going to go ahead and cancel these out early, and I'm left with 180 over 1, which is 180 degrees. So pi radians is 180 degrees. Okay? All right, let's do another example. Give you one a little bit bigger here. So let's see, 6 pi over 4. I'm trying to think of something a little bit different. Okay, let's do 7 pi over 6. So I'm going to take 7 pi over 6 radians. Again, radians has to do with the circumference of the circle. It's the portion of the circumference. If I've got 7 pi over 6 radians and I want to convert that to how many degrees that would be in the circle, I'm going to multiply by 180 over pi because I know there's 180 degrees for every pi radians. Okay? So what I'm going to do here is I'm going to look at what can cancel out the pi's. So I have 7 times 180, 705, so that's 1,260. And on the bottom we have 6. Again, the pi's go away. I wrote them out for you up here just in case you felt like you needed to go ahead and write them out and cancel them here, but you can cancel them ahead of time. So I've got 200. 6 goes into 12 how many times? Okay, twice. And then I've got 1 and 0, so 210 degrees. So 7 pi over 6 is 210 degrees. So that is how you convert from radians to degrees. Now, I want to do one extra example because sometimes we're going to get things that are bigger than 360. Look at the circle. Think of this as a tire on a car. If this is a tire on a car, if I go 1 revolution, I've gone 360, right? But if I go 2 revolutions, I've now gone 720, right? Think about the Olympics, the snowboarders. Okay, the snowboarders, they do 900s and 720s and all of those. That's because that's the total number of degrees that they rotate when they're in the air. 2 circles is 720. 3 circles would be 1080. Okay, so 2.5 circles would be 900. So that's what they're looking at when they're telling you what these snowboarders are doing, how much that they're rotating. So you're going to get radians sometimes that are actually going to give you something that's greater than 316 degrees. Okay, 360 degrees, sorry, not 316. So let's look at an example of that. Let's see. Let's do 7 pi over 2. Okay, I want to know how many degrees is 7 pi over 2. Well, I'm going to take 7 pi over 2. I'm going from radians to degrees, so I'm going to put the radians on the bottom, just like I did. I went from inches to feet, so inches went on the bottom. So when I multiply across, the 2 pi's cancel out. I get 1,260 on top. I get 2 on the bottom. And that's going to come out to 630 degrees. 630 degrees is not quite 2 complete circles. 2 complete circles would be a 720. But it's more than 1 rotation. Okay, so that's how we convert from radians to degrees, and that's why we use that concept. Again, radians are a portion of the circumference. Okay, measure means that's the angle. The length means it's actual length and portion of the circumference, which is why we use radians.